Hi, today we are going to see about error control for digital satellite links and DRSS. Error control coding. The primary function of an error control encoder decoder pair is to enhance the reliability of message. An error control code can also ease the design process of a digital transmission system in multiple ways, such as the following. The first one is the transmission power requirement of a digital transmission scheme can be reduced by the use of an error control codec. The second one is even the size of a transmitting or receiving antenna can be reduced by the use of an error control codec while maintaining the same level of end-to-end performance. And the last one is access of more users to same radio frequency in a multiple access communication system can be ensured by the use of error control techniques. The major categories of activities on error control coding can broadly be identified as the following. The first one is to find codes with good structural properties and good asymptotic error performance. The second one is to devise efficient encoding and decoding strategies for the codes. And the last one is to explore the applicability of good coding schemes in various digital transmission and storage systems and to evaluate their performance. The block diagram and the different forward error correction codes is given in this figure. The forward error correction code is subdivided into block codes and convolutional codes. Under block codes, binary codes are there. For example, Hamming, BCH code, Gole code, fire codes comes under binary, and read Salmon codes comes under non-binary. The non-binary is also subdivided into systematic and non-systematic. The convolution codes is classified into non-binary and binary. Under binary, systematic, that is the turbo codes, and under non-systematic, Viterbi algorithm comes under. Implementation of error reduction on satellite links. The following three basic techniques can be used, which are based on the type of the link used for retransmission request. In a one-way simplex link, the acknowledgement and the non-acknowledgement signal must travel on the same path as the data. So the transmitter must stop transmission after each block and wait for the receiver to send back a NAK and a ACK before it retransmitted the last data block or sends the next one. The data rate is very slow and thus useful for links in which data are generated slowly. In a stop and wait system, the transmitting end sends a block data and waits for the acknowledgement to arrive on the return channel. Though the implementation is simple, but the amount of delay is the same as complex case. In a continuous transmission system, using the go back end technique, data are sent in the form of block continuously and held in a buffer at the receiver of the end of the link. When the data block arrives, it is checked for error and appropriate ACK or NAK is sent back to the transmitting end with block number specified. When a NAK is received, the transmit end goes back to block N and retransmit all subsequent sequences. Data relay communication systems, that is DRSS. It is primarily meant for providing continuous or real-time communication of low Earth orbit satellites and human space mission to the ground station. A data relay satellite in the geostationary orbit can see a low altitude spacecraft for approximately half an orbit. To such relay satellites spaced apart in geo could theoretically provide continuous contact for any space in LEO. The architecture of a generic DRSS satellite is DRSS space segment. The DRSS space segment primarily consists of high altitude satellite system of GEO or MONIA class, divided in a modular way, providing several payloads satisfying the data relay service requirements at different orbital positions with onboard state-of-the-art technologies. Second one is DRSS ground segment. DRSS Network Control Center, whose task will include managing and operating the end-to-end delay links and to provide data relay customer interface for mission request, mission planning, scheduling, and mission execution. The last one is DRSS user segment. The user of DRSS services can be broadly categorized as institutional users, for example space agencies, and commercial users, for example other launchers, satellite agencies. Thank you.